For the last section in the packet, we need to understand what the different parts of the coordinate plane are. Remember, the coordinate plane is made up of two intersecting lines. The line that runs from left to right is called the x-axis, and the line that runs up and down is called the y-axis. Because of the two intersecting lines, we have four main areas where we can plot points. You can also plot points on the x and y axes themselves. In algebra, we call these four areas quadrants, and they're numbered quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Notice that they're numbered with Roman numerals. In the packet, you'll see them with Roman numerals. Sometimes you can see them with regular numbers 1, 2, 3, and 4 as well. In the coordinate plane, you can plot points using ordered pairs. An ordered pair is always made up of two coordinates, the x-coordinate first, comma, and then the y-coordinate second. So if I had a point here in the coordinate plane, I would write down the ordered pair that goes with that point by first counting the number of spaces that I move on the x-axis and then the number of spaces that I move on the y-axis to get to that point. Remember that when you're counting on the x and y axis, you always start at the origin in order to count to find the ordered pair. So if I start at the origin, or 0, 0, I'm counting 3 spaces to the right and then 2 spaces up. So the ordered pair that goes with that point in the coordinate plane would be 3, 2. Notice that both of these numbers are positive. For the 4 quadrants, there's different things that you can characterize about the points that fall in each quadrant, specifically the signs. So because I have 2 positive numbers here, I automatically know that that point is going to fall in quadrant 1, because quadrant 1 is made up of all the points that have a positive x and a positive y. In quadrant 2, because we're moving to the left on the x-axis, all of the points in quadrant 2 will be a negative number followed by a positive number, because I'm moving to the left on the x-axis, but we're still moving up on the y-axis, which would mean the y-coordinate is positive. In quadrant 3, because we're moving to the left and then down, quadrant 3 is made up of all ordered pairs where both coordinates, both x and y, are negative. And in quadrant 4, because we're moving to the right and down to get to points in this area, these points would be positive for the x and negative for the y. If you're asked to evaluate an ordered pair in a given equation, it might be worded something like this. Is -3, 9 a solution of the equation y equals -2x minus 10? The first thing that you should do is label the ordered pair. So remember, we said that ordered pairs are always an x-coordinate followed by a y-coordinate. Once I know that -3 is my x value and 9 is my y value, all I have to do is substitute and then simplify and see if the statement is true. So 9 is going to get substituted for y in this equation that's given to me. And then I have -2. Instead of x, I'm going to substitute in a -3 minus 10. I want to use my order of operations to simplify this side. So I get 9 equals +6 minus 10. And if I subtract 6 minus 10, that actually gives me a -4. Notice that these two sides of the equation are not equal to each other. So because the two sides are not equal to each other, I can conclude that -3, 9 is not a solution for the equation y equals -2x minus 10.